So let's start with theory of derivatives. So as you can see, derivatives is instantaneous rate of change. What is instantaneous rate of change? When I talk about rate of change, that means what? Let's say final distance minus initial distance traveled upon time taken, let's say 2 hours. So it's going to be 10 kilometer in 2 hours, and that we get it as 5 kilometer per hour. Now this is not instantaneous, like, because we took a lot of time, 2 hours from this 20 kilometers to 30 kilometers, so we can travel 10 kilometers in 2 hours, so it's going to be 5 kilometer per hour, which is nothing but the speed or velocity, whatever you want to say. But when it comes to derivative, it is instantaneous rate of change, meaning, so let's say there is this curve which is traveling in this way, and this is distance or f of x at that point. So here if I talk about this point a, and then there is this next point which is a plus h. So see, here a is increasing from a to a plus h, and h is very 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 small, like hardly 0 infinite 0 after that one. So the thing is, this is going to be f of a, and this is going to be f of a plus h. Now if I just find out what is the difference, what is the instantaneous rate of change, that means what? F of a plus h minus f of a upon a plus h, that is the final distance minus final time minus the previous time, a plus h minus a, which is going to be h, and provide that h is very very small. Now what could be the least value of h? It is nothing but limit h tends to 0. That means what? It is almost 0 but not 0. So as you can see, this is nothing but your f dash of a. That means what? Derivative at that particular point, that is a. In general, if I talk about, you can see the first principle of the derivative is going to be limit h tends to 0, where h is very 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 small, like 0 infinite 0 after that one. This is going to be f of x plus h minus f of x upon h. This is nothing but your first principle of derivative. With respect to that, we find the derivative of some common function. So as you can see, x to the power of n is nothing but nx to the power of n minus 1. So maybe if I talk about x to the power of 3, the derivative of this thing is going to be what? It's going to be 3x square. Similarly, root x, since it's we can just find out like this only, like x to the power of 1 by 2, and then it's going to be 1 by 2 x to the power of 1 by 2 minus 1. But since we use it quite a lot of times, that's why I've just written it 1 by 2 root x as a special derivative. E to the power of x, e to the power of x, ln x 1 by x, sin x cos x minus sin x, and tan x square x. Obviously I think you should know it. And derivative of constant is 0 because there is no change, like it's just constant, like constant constant, the distance is constant basically, or constantly it is moving, so there is no change. So that's why the derivative of constant is going to be 0. There are some rules of derivatives. The first one is general rule. If there are two functions, f of x plus minus k, where k is a constant, g of x, then we can just separate it from plus minus. That's going to be f dash of x plus minus k into g dash of x. That means what? Here I am combining two properties. One is that you can distribute the derivative from plus minus. Second thing, you can take out the constant outside. For example, if I want to find derivative of sin x, sorry, derivative of 5 sin x, I can take out this 5 outside, and it's going to be 5 sin x. Sorry, 5, and derivative of sin x is nothing but cos x. That's going to be the answer. Then we have product rule. If there is a multiplication of two function, f of x into g of x, generally are represented by first and second. So derivative of this function, like product of functions, is going to be what? It's going to be first into derivative of second plus second into derivative of first. We will see in the questions later. Quotient rule, when it is numerator upon denominator, so it's going to be denominator into derivative of numerator minus numerator into derivative of denominator upon denominator whole square. Whole square meaning, if by chance in denominator we have 2x plus 1, so we'll just take square, or we are just not going to take the individual square, we are just going to make it completely whole square, 2x plus 1 whole square. Then we have something which is very important, that is chain rule. Now that is basically derivative of composite function. As you can see here, composite functions derivative. So see here, first of all, we need to understand how to identify these composite functions. So let's see. So if I talk about identifying product or chain rule, so we are going to use chain rule for this composite function for sure. Now, what we need to understand, so I've just taken two of the example, very simple, sin x into cos x and sine of cos x. Now just time, what we can do just to identify whether it's a composite function or just a normal function, like product of the functions or just function upon function. So what we are going to do, we are just going to put x is equals to 5, a random number I am talking about. If I just put x is equals to 5, f of 5 would be what? Sine 5 into cos 5. That means what? Directly we are getting the answer, and that's going to be your, like, obviously we are going to use product rule for finding the derivative. I've solved it, you can see it later. But when I put x is equals to 5 in this function sine of cos of 5, then first we need to find cos 5, whatever the values, that value sign I'll have to take and I'll get answer. So basically I'm taking 2 steps to get the final answer. And this is nothing but your composite function, and for that we are going to use chain rule. Now how to do this thing? So we will first figure out which is the outermost function, and then we'll go inside like that. Okay, so as you can see, when it is sine of cos x, the outermost function is sine, right? This outermost function is sine, and then after that we have cos. So what we are going to do, we're going to find derivative of outermost function, which is sine first. So derivative of sine is nothing but cos, so I've written cos. Okay, cos of whatever it is as it is, so cos of cos x, I'll just consider that cos x as x. We'll do it in questions as well. So cos of cos x into derivative of whatever is inside, which is nothing but cos x derivative, which is nothing but sine minus sine x, and then we'll simplify. That's your answer. The first application is gradient of the tangent. So as we know, the first principle is what? F of a plus h minus f of a upon h. So as you can see, if there is this curve like this, the gradient of the curve is generally y2 minus y1 upon x2 minus x1. Here if I talk about when it's an instantaneous change, here y2 is nothing but your f of x plus h, y1 is nothing but your f of x, and x plus h is your x2 and x is your x1. As you can see here also, this is your y2, sorry, this is your y2, y1, x2, x1. And so we directly, so basically derivative is just giving me a gradient of a line passing through 2 points, and those 2 points are so close to each other that they are just they both form just 1 point. Understand? Again, I'm just repeating the same thing. See, if there is this curve, if I'm talking about f of a, and if I'm just doing f of a plus h, now these points are so close to each other, they are just next to each other. Think about it. H, the value of h is 0 infinite 0, and after that 1. So it's impossible. So we are talking about a point just next to it, so we'll consider that point as just 1 point only. So that's why we will get derivative, so sorry, we will get the gradient of the tangent at that particular point. So see, that's what I've written. See, since f of x plus h and f of x are so close that we can consider them as 1 point, therefore f dash of x gives us gradient of tangent. To find gradient in any of the questions, what we are going to do, we're just going to find f dash of x, put x wherever we want to find the tangent at. Okay, so for example 2, 3, 4, 5, 6, 7, whatever you want to put, so you'll just put it. So we'll get gradient of tangent at x is equals to 2. Now they may okay, so that is basically gradient. So, and we need to find the equation of tangent, and for equation of tangent we require 2 things, gradient and point. So we know the gradient through that derivative thing, just putting x is equals to 2, we got the gradient. So we got the gradient, there's no problem. What about the coordinate? X coordinate we already know. As you can see in this example, it's going to be 2. Now for finding the y coordinate, you just put that 2 in this f of x equation, you will get the y coordinate, let's say 5. So we know the gradient, we know the point, we can find the equation of tangent. Second thing, if they ask you normal, point is same, of course, no problem. Only thing is, with respect to the gradient of the normal would be minus 1 by, like, reciprocated and change the sign, you will get the gradient of the normal. Same thing. Application 2 is stationary points. So as you can see, if I want to find, like say, we are finding tangent at various points. Now, if we talk about some point like this, which is the maximum point, we can say, and we generally say it as a local maxima, like, you know, maybe the curve is turning like this also, here also it's going to be a maxima. So that's why we say local, matlab like that area ka maxima, whatever. So here, if I am talking about this maxima at this point, so here you can see that the, like if I make a tangent out of it, the gradient will be 0. On the other hand, when it is lowest also, when it is very, like whenever it is minima also, local minima again, because even the curve could go like this and it can go like this as well. So here also it can, there could be minima. So there could be couple of minimas, like many number of minimas and maximas as well. Now here, if I talk about this thing, so the gradient is going to be 0, right? Because we are finding the derivative of that function, and then if I put that coordinate, and if I'm getting that 0, the gradient is 0, that means what? It is like this flat line. So if I get a flat line, then it could be either maxima or minima. So as you can see, f dash of 2 gradient, like I've just given you an example. So at 2, you can see that the gradient is 4. I'm just taking a random value. Okay, gradient at 5, it is 0. Gradient at 10, it is again 0. And maybe here you can say, so the gradient could be negative or something like that. So as you can see here, at 5 and as well as at 10, we are getting gradient as 0. The moment we get gradient as 0, that could be local maxima or minima. But how to determine that? We don't know the graph of this function. So to determine that thing, we just need to double differentiate it. Like differentiating f of x once, we get f dash of x. We differentiate again, we get f double dash of x. So if we, for that f double dash of x, and whatever that x value we are going to put, that 5 or 10 or whatever. So if we get d2y by dx square, that is f double dash of x, and we just substitute f double dash of 5 in this case, okay, we will get a negative value. And here if I substitute f double dash of 10, then we'll get a positive value. So as you can see, if I get negative, then it's going to be maxima. If it is positive, then it's going to be minimum. By chance, if you get 0, which you don't have in the syllabus of your Advanced 606, then it's point of inflection. Anyways, so this is what you have in stationary points. Third application is small increments. Now again, we're coming back to the same first principle thing. So if I talk about f of x plus h minus f of x, see, we are done with the gradients now. We are talking about now small increment. So if I have we know that f dash of x is nothing but f of x plus h minus f of x upon h. That is nothing but your first principle. I'll rearrange something and I'll get f of x plus h is equals to f of x plus h into f dash of x. Just shifting h on the other side, f of x on the other side, and we'll get it. Understand? Again, see, I'm mentioning again and again that h is very, very small. So that's why we say small increment. Now the thing is, if I'll just take an example. If there is a function f of x is equals to x cube, so f of 2, like 2 cube is nothing but your 8. But if I want to find 2.001 cube, okay, you will understand like properly afterwards. So if I am talking about 2.001 cube, like see, 001 is not like 0 point infinite 0 and after that one, but it is very small, quite small, 0.001. So we can consider that thing as h. Okay, so we can write f of 2.001. That means what? We need to find 2.001 cube. So we can write this thing as a plus h, like 2 plus 0.001. The moment I write this thing, f of 2.001 according to this thing would be what? F of 2 plus 0.001 into f dash of 2. Now let's see, the calculation becomes so simple. It's going to be h into f dash of 2. Now f dash of x is nothing but 3x square. I mean, just finding out the derivative. And we'll just put f dash of 2. So we'll get 3 into 2 square. I mean, that's whatever it is, the value is going to be. It's going to be 12. And that I multiply by 0.001. So I'll get 8.012 after solving everything. And this is nothing but the cube of 2.001. Now see, remember, this is the approximate value. This is not the accurate value. Okay. Because this is like, small increment with the derivatives. We are just estimating this is going to be the answer. This is not going to be the accurate answer. Okay. But just using derivatives without calculator, you can find 2.001 cube in short. Now, amount of increment, most of the questions are generally asked like this. What is the amount of increment, or how much it has changed, or something like that. So that time they are just asking the h into f dash of a. Mostly they will ask you this thing only. So h into f dash of a. Total value is f of a plus h into f dash of a. But this increment, the small increment, I mean, obviously, if h is negative, like even if I talk about 1.9999, so then it's going to be 2 minus 0.0001. So here h would be negative then. So the amount of increment would be negative. So it's just going to be h into f dash of a. We have taken the question. So they will ask you f of x, they will ask you f dash of x, they will ask you f dash at that particular point, and they will ask you hence if that particular value to plus h happened. So how much is the increment which will happen? It's going to be h into f dash of a. We'll see in the problems. Application 4 is related rates. So as you can see, related rates means what? So we'll take directly an example, and this is based on the composite function. So see, f is dependent on g, g is dependent on t. At the end of the day, f is dependent on t. Okay, let's take an example. Suppose you throw a stone in water, one ripple is formed. Let's assume that there is just one ripple which is forming. Now with respect to the radius will increase, the area will increase, the circumference will increase. All three things are changing, and all of these three things are changing because of this element which is time. Because the time is changing, that's why everything is changing. If you stop the time, then nothing will change. But the thing is here, because of time, everything is changing. Now the thing is, area, see, one more important thing is that radius is maybe increasing constantly, let's say, some of the elements. But area won't increase constantly. Then circumference will also not increase constantly. Radius may increase constantly, okay? So maybe there is just constant, that radius is increasing with 2 centimeter per second. But area and circumference won't be like that. Like area will become huge, huge, huge. Like it will keep on growing. Like the the rate at which the area will increase will be too much as compared to the radius. Radius is constantly increasing. So how? Now a is nothing but pi r square. Now differentiating with respect to t, we get what? Now see, this is important. Huh? We are differentiating with respect to time t because time is common with everything. So di by dt is nothing but, see, pi is a constant, so I just kept that pi a constant outside. Derivative of r square is nothing but 2r into derivative of r with respect to t, that is nothing but dr by dt. As you can see, we just saw dA by dt is, like, is equal to pi to r dr by dt. So the rate of change of area is dependent on the rate of change of radius. Now how to follow the steps, we'll see in the problems, don't worry. So write down the given condition first, form an equation in terms of just one variable. Now this is very important. If there are two variables or three variables involved, generally two variables are involved, so you better convert everything in terms of one variable, then differentiate it with respect to t, put the values, get the answer. Last application is, yes, last application is optimization, maxima or minima. Same thing, remember, for this thing, stationary values, when we had that f dash of x is equals to 0. So the application is basically simple, that if I want to minimum perimeter maximum area, or maximum volume but minimum surface area, that kind of stuff, if I want to do, then we use optimization. What does that mean? That if I just convert a function in terms of one variable, again same procedure, this thing only, and then if I just find f dash of x where I'll get 0, that will give me minimum or maximum value. Same stationary point, you just have to figure out that x value, you just have to prove that it is maxima or minima. That's all you have in derivatives. So yeah, I mean the procedure is same. The values of x, say a, will give you, just a second, will give you maxima or minima. Find f double dash of x and f double dash of a and check for maxima or minima. That's it. That's all you have in derivatives theory. Now let's start with the problems.